if you are given a velocity time graph like this, in the y-axis you have your velocity, on your x-axis you have your time. So if your graph is increasing as any straight line like that, it means your velocity is increasing uniformly. This simply means that the velocity is changing at the same rate, okay? And then in this case, the acceleration will be constant. And if you have a graph which is like that, your velocity is decreasing uniformly and acceleration is negative, so you have a negative acceleration. Lastly, if you have a graph which looks like this, velocity and time, so in this case your velocity, you can check, if you check any time interval here, at this time the velocity is there, at this time the same. So if this is 5 meters per second, it means at 0 seconds the velocity is 5 meters per second. At 10 seconds the velocity is still the same. So in this case the velocity is constant, but the acceleration will be 0. We are saying acceleration is 0 because the gradient is 0 for this kind of graph, okay? Another thing you need to take note of, if you are given a position time graph, for you to find the velocity, you must calculate the gradient, okay? And if you are given a velocity time graph, you want to calculate the position, you must calculate the area. Alright? And if you are given a velocity time graph again, you want to calculate acceleration, you must calculate gradient. And if you have acceleration time graph, you want velocity, you must calculate area of the graph. Okay, so you need to understand that basic information. So now looking at this graph, they say write down the initial velocity of the car. Initial, it means at time 0, so you go to the x-axis and read the time. So on your x-axis, that's where you read the time. This is your x-axis. So at time 0, there it is. Then you check on your y-axis, you must read your velocity. You can see the velocity is also 0 there at the y-axis. So you have 0 meters per second. And then at 10 seconds, again we go to the x-axis and read 10 and match it with the y-axis. So if this is 5, it means 10 is somewhere here. So I have 10 seconds here. Then I must go to the y-axis and read the graph. I have a value of 40 meters per second. Alright? And then I said describe the motion of the car for the section level CD. If you are asked to describe motion, you must describe what is happening to the velocity and what is happening to the acceleration. So CD, you can see the graph is moving down at a uniform rate. It's changing at the same rate. So then it means the velocity is decreasing uniformly. You can see the graph is decreasing uniformly because you have a straight line going down, and then that means your acceleration is negative, right? And then number 4, it says support your answer by calculating the acceleration for CD. I just explained now to calculate acceleration from a velocity time graph. If you want the acceleration, you must calculate gradient, or you can simply say, okay, this is 4.4. Acceleration is change in velocity, which is Vf minus Vi over T final minus T initial. So if you move from CD, wherever you're starting, that is your initial point, and where you end up, that is your final point. So initial my initial point will be at C and my final point will be at D. So it means my V initial is at C, so I must read it at C. Initial velocity, I check it on the y-axis. I have 40 meters per second. Then the initial time, I must check it on the x-axis. That is 20 seconds. Then when I go to D, I must find my final velocity. At D, there is the point at D. I must check the velocity on the y-axis. It's 0. So I have 0 meters per second. And then the time, which is the time final in this case, at D, there it is, that is 25 seconds. So you just plug it in your equation. VF, that is 0 minus 40 over TF, which is 25 minus 20. Then you get negative 8 meters per second squared. You've just proved that your acceleration is negative. You have a negative acceleration, the car slowing down, right? So that is how you analyze this kind of graph. In the next video, I'm going to explain how you can calculate the displacement, okay? But before that, let's compare the motion from C to D and from D to E. To check which one is faster, just check how long does it take for the car to reach D from C. You can see it takes about 5 minutes. And from D to E, it takes about 2.5 minutes. So which point is faster? Obviously DE. The acceleration is faster in DE than in CD. Another thing you can explain using the steepness of the slope. So this slope is steeper than the slope at CD. So that's how you're going to explain 4.5. So you can simply say DE will be greater than CD because the slope of DE is steeper than the slope of CD. In the next video, I'm going to explain 4.6.